This is practice problem number 1 from lesson 4, comparing proportional relationships. And in these problems, be sure to go back to the 4 representations. Think about these 4 representations: equation, description, table, and graph. And you're going to be given 2 of those representations to work through this problem. So think about the equation that we started with a long time ago, y equals kx. The constant of proportionality, the unit rate, the slope, what the comparison of the number of units in the vertical direction compared to the number of units in the horizontal direction. Where's the origin? Where the x and y axis meet? What does that mean as far as a proportional relationship? The slope triangle is going to be shoved right up against that origin. The table, x values, y values. The constant of proportionality is y divided by x. So forever, how many units of x you have, you get a certain amount of y. So what is the amount of y per 1 unit of x? Make sure when you look at graphs, think about what the labels of the axes are and the units. So in this case, you have easy excavation. And so that data is shown in the table on the left here. And happy hauling services is the data shown on the right. These are services that will haul away large amounts of dirt. Actually, it says large amounts of dirt to a work site. Must haul large amounts of dirt to a work site. So you're going to take dirt to the work site. So they charge a certain amount of money per cubic yard of dirt. Now, you don't really have to know what a cubic yard is. You just have to know that's a unit of measure for the amount of dirt that they move. And you have these questions to answer. You're going to haul 40 cubic yards of dirt to the work site. So how much is that going to cost? How much would each hauling company charge to haul 40 cubic yards of dirt? Calculate the rate of change. That means the unit rate. So for every unit of cubic yards of dirt, how much does the rate change? What is the unit rate? How much does that cost? And if the contractor has $1,000 to spend and 40 cubic yards of dirt to haul, which company should he choose? All right, so let's look at the table and get to the equation. At least let's begin with looking at the slope, or the constant of proportionality. So if you take the cost in dollars, $490 per 20 cubic yards of dirt. So that's cost per cubic yards of dirt. So this is the y value on the right side and the x value on the left side. And it makes sense. You're going to put the 20 yards of cubic dirt into the equation, and you're going to ask, how much is that going to cost me? I want to know how much I have to spend to haul that 20 yards of cubic dirt. And that's $490. So to get 1 yard of cubic dirt, you divide that 490 up among the 20 cubic yards of dirt, and you're going to get $24.50, $24.50 for 1 cubic yard of dirt. And the graph, how can you find that same information? Basically, what's the unit rate? How much is it going to spend? How much is it going to cost me for a cubic yard? Well, look at where this line crosses 2 of the grid lines on the graph, where those grid lines intersect and this line intersects with those. That's going to be an easy point to choose to look at. So that happens, the first time that happens is right here, and other than 0, 0, by the way. It's right here. And so if you have 1 cubic yard of dirt to haul, it's going to cost you $25. And that turns out that that is the unit rate. How much does it cost for 1 cubic yard of dirt? $25. So it costs, so Easy Hauling Company costs $24.50. We already figured that out. And that equation is the money is equal to $24.50 for every 1 cubic yard of dirt. So that's the equation. This is the unit cost, $24.50. For Happy Hauling, they charge $25 for 1 cubic yard of dirt. So that equation is the amount of money is equal to $25 for 1 cubic yard of dirt. So this is the y value divided by x, so 25 divided by 1. So you can see that Happy Hauling Company charges 50 cents more per cubic yard of dirt. $25 for a cubic yard, 50 cents more per cubic yard of dirt, $24.50 per cubic yard for Easy Hauling Company. So for 40 cubic yards, how much does it cost for each company? Well, Happy Hauling, this costs $25 for 40 yards of dirt. That's 40 times 25 equals $1,000. So, but Easy Hauling is less expensive. It costs 50 cents less per cubic yard. So it's going to cost $24.50 times that 40 cubic yards. And so you're going to save $20. $980 is what it's going to cost. And so if your budget, you only have $1,000 to spend, which one are you going to choose? You're going to choose more than likely the Easy Hauling Company, if cost is the only factor. There might be other factors involved, the reputation of the company, other information that you might have, whether or not you choose Happy Hauling, even though it's less, or you choose Easy Hauling, even though it might be a little bit more expensive. Might be a better deal. All right. So it costs you $20 less to use Happy Hauling. And this is problem number 1. This is practice problem number 2. Lesson 4, comparing proportional relationships. And we're going to go back to this once again. It's 4 representations. In this case, you're going to be given a description and an equation. And you're going to be asked a few questions about those and to compare those proportional relationships. So the equation, remember that the K value is the constant proportionality, it's the unit rate. The table, actually you're given a description. All right, so let's look at this. Andre and Priya, they're keeping track of the number of steps they walk, and they walk a certain number of steps per a certain amount of time in minutes. So Andre says, gee, I can walk 6,000 steps in 50 minutes. So he records that he does that. Priya writes an equation for her walk, 118 times x, and they tell you y is the number of steps. So you are going to calculate how many steps given how much time she walks. So in x number of minutes. So now notice if you look at her equation, the direction in the number of units in the vertical direction, which is y, is 118 times greater than the number of units in the horizontal direction. It's 118 times x. So she walks 118 steps each minute. And for Andre, it's going to be 6,000 steps per 50 minutes. So you want to get this down to how many steps in 1 minute. So this is going to be the y value, 6,000 steps. It's going to be consistent with Priya. And this is going to be the x value. And another way that you can tell that is that the number of steps is much greater than the time. So it's actually 118 times greater than each minute. So you're going to get an answer for y that's much greater than what you're measuring as far as the time. And then you're going to be asked, how many steps do they walk in a total of 5 hours? And who walks more steps? How many more steps? All right, Andre, 6,000 steps in 50 minutes. So 6,000 steps per 50 minutes is how many steps per minute? Well, you just divide each of these by 10 and you get it down to 600 steps per 5 minutes. And 600 divided by 5, well, 60 divided by 5 is 12. So 600 divided by 5 is going to be 120. So 120 steps per each minute. That is the unit rate. How many steps do you take in 1 minute? Then in 2 minutes, you take twice as many as that. 3 minutes. So 5 minutes, you take 5 times 120 or 600 steps. and 50 minutes, you take 50 times 120, or 6,000 steps. So it's also the constant of proportionality. So this is the number that's going to be multiplied by x in the equation. So y is equal to 120, that's k, constant of proportionality, times x. So notice that the vertical, the number of units in the vertical direction, which is the measure of steps, is 120 times the horizontal measure, which is a measure of minutes. So however many minutes you walk, you multiply that by 120. Now Priya is taking fewer steps in that amount of time. So she's walking 118 steps per minute. So this is her equation. So this is the 118 compared to the 120 for Andre. So Andre walks 2 more steps per minute. How do you get that? Well, 120 is 2 more than 118. So Andre takes 2 more steps for each minute. So over 5 hours, that is 300 minutes. He takes 2 more steps each minute. So how many steps farther does Andre, how many steps more does Andre take? He takes 600 more steps, 2 steps per minute times that 300 minutes for the 5 hours. That is equal to 600 more steps. So who takes more steps? Andre takes more steps. And how many more steps in 5 hours? He takes 600 more steps in 5 hours. Notice it doesn't tell you about distance. So we actually don't know if he walked farther. Maybe he takes smaller steps. So he takes more steps in each minute. This is practice problem number 3, and I'm going to break this problem up into 2 parts, 3A and 3B. So when you look at this problem, there are 2 triangles, and so we're going to work with one triangle on the left, that'll be part A, and this triangle on the right side, that'll be part B. These are not proportional relationships, so we don't have to deal with all the representations, but this part is on the graph. We're going to look at slope triangles that do not go through the origin, and one of the tasks is to get them to go through the origin so that you can figure out the equation. So this is going to be harder than just saying y over x. You're going to have to subtract or add something to y and subtract or add something to x. So if you just visually look at these 2 triangles, you can begin to get an idea of what's going on. So this triangle on the left, we want to get this triangle to be at 0, 0 so that we can figure out the distance along the horizontal axis and compare that to the distance along the vertical axis. And we also want to be able to figure out the slope. So we're actually going to end up sliding this triangle over 6 units to the right. Because this is at -6, we're going to add 6 units to it and slide it over to the right. And we're going to use, there's 2 slope triangles here. There's the smaller one that goes to this point D, and there's the larger one that goes up to this point 2, 10. And your task is to find the coordinates for point D. Well, one of the x-coordinate is 0 because it's at the origin. So it's going to be at 0, and then you have to figure out how far does it go up on the y-axis. Well, to figure out the slope, you might be able to see right away that you're going to take this 10, you're going to subtract 0 because it's already along the x-axis. So this number of units in the vertical direction is 10 units. And you might be able to see just by looking at it that the number of units in the horizontal direction is going to be 8 units because it's this 6 units plus 2 more. But I've already said too much. We're going to do that mathematically in a few moments. But if you look, so the point here is that the y coordinate, you don't have to add or subtract anything to y. The vertical distance is the y coordinate because it's already resting on the horizontal axis or the x-axis. But you do have to add to the x value or subtract depending on how you're looking at it, and we'll get into that. But the point is that you have to move this triangle along the horizontal axis, along the x-axis, to get it to this point here, 0, 0. This triangle on the right, you have to do both. You have to both subtract some values to to lower this or to make this move down to the horizontal axis, and you have to subtract some negatives or add some positives to slide this to the right. So we will do both of these mathematically. And this is part A. I'm going to go through writing the equation and figuring out the slope, and then I'm going to visually show you what's going on a little bit later. This is long, and it's pretty hard, and so you have to really pay attention to what's going on. So we're going to use point D to write the left side of the equation. So we're going to use x and y as point D right now, and we're going to use this point 2, 10. So the x value is 2, the y value is 10, and this point down here, -6, 0, to figure out the slope. So remember that the left side are the x's and the y's. So how do you figure out what the x's and the y values are to begin with? Well, the y coordinate, you don't have to, it's y right here, you don't have to add or subtract anything to y, it's just y, because it's already along the x-axis. But the x value, you have to subtract this -6 to slide this slope triangle right here over. And I'm going to show you this visually in a little while. You have to subtract that -6, which is the same as adding 6, to slide this triangle over to 0, 0. So this equation becomes y, the number of units in the vertical direction is y, but the number of units in the horizontal direction is actually, number of units in the vertical direction is y right here, but the number of units in the horizontal direction is actually whatever this x value is plus 6, because you have to figure out that these are 6 units here that gets added. Kind of messing this up. So the equation is y in the vertical direction over compared to x plus 6, because you're sliding this over 6 units. Now what's the slope? The slope is the number of units in the vertical direction, so that's 10 units. That is right here, so it's 10 minus this 0, or 10 minus this 0 right here, same thing. So this number of units in this vertical direction is 10 units, but what's the number of units in the horizontal direction? Well, it's the 6 plus 2 more units. So this is 2 minus a -6. Well, 2 minus a -6 is adding the 6 units to the 2 units. So what's the total? The total is 8 units. So the slope is 10 units in the vertical direction, these 10 units right here, and 8 units in the horizontal direction, 2 minus a -6. So this 2 right here minus a -6 tells you that this difference, this distance from this point to this point is 8 units. So that fraction is 10 over 8, or that ratio is 10 over 8, which simplifies to 5/4. So that what that tells you is that the number of units in the vertical direction is going to be 5/4 times the number of units in the horizontal direction. So it's going to be the number of units in the horizontal direction plus 1 more fourth. It's going to be 5/4 times that. So this is the equation right here. Y over x plus 6 is equal to 5/4. So that's what we're going to use. So if the y value is just the y value, it's the number of units in the vertical direction, but the number of units in the horizontal direction is, if x is 0, so right here, x is 0, it's 0 plus 6, that's going to equal 6 units. And that gets multiplied, the y is 5/4 of that 6 units. So y is equal to 5/4 times 6. The number of units in the vertical direction is 5/4 the number of units in the horizontal direction. That's why this gets tough. What are the number of units in the horizontal direction? They are 6 units. How do you get that? It's this 0 plus 6. It's figuring out what this length is right here. And the x value right here is 0. So it's 0 plus these 6 units. So the number of units in the vertical direction is 5/4 of 6. So 5/4 of 6 is 6 plus 1 more fourth of 6. Well, what's 1/4 of 6? That is 6/4. That's the same as 1 2/4. That's the same as 1 1/2. So you add 1 1/2 to 6, and you get an answer of 7 1/2. This is hard, and if you're not comfortable working with fractions, you just have to go through this, look at it a variety of different ways, and keep on working at it. So the left side of this equation is y over x plus 6. X minus a negative 6 is the same as x plus 6. And that equals the slope, 5/4. So the number of units in the vertical direction compared to the number of units in the horizontal direction. So what are the coordinates? The coordinates are 0, and the y coordinate is 7 1/2. So 0 and 7 1/2. So this 7 1/2 is equal to 5/4 times these 6 units right here. So if I go 6 units from this point, if I go 6 units in this direction, how far do I have to go in the vertical direction? I have to go 5/4 of that 6 units. 5/4 times that 6 units. And that is equal to 7 1/2. So we know that that point is 0, 7 1/2 right here. So let's go through this visually, and that might make it a little bit easier for some of you, and for some of you it's going to be even more confusing. But it's a visual example of what's going on. So what are we doing is that we are sliding this slope triangle over 6 units to the right. So we're moving this over 6 units, so the x value becomes 6, and the y value is y, because we don't have to slide it up and down at all. So the number of units along the horizontal axis is 6 units. The number of units along the vertical axis is y units. So this is y units, this is 6 units. So it's going to be y over 6. Now what's that equal to? That is equal to the slope. That's equal to this 5/4. So the number of units in the vertical direction is equal to 5/4 times the number of units in the horizontal direction. So that y right there is equal to 5/4 of these 6 units. Because I slid this over 6 units to the right. So now this is, you put this right at the origin. So these are now 6 units, and the vertical direction is y units. So what is 5/4 of 6? Well, 5/4 of 6 is equal to that 7 1/2 once again. So the number of units in the vertical direction is equal to 7 1/2. All right. So now this is where we subtracted a negative 6, or we added a positive 6 to move it over to here. But now we're at this point up here. Well, we don't want to be there. We want to be at point D. So what do you do to get back there? You have to take these 6 units away. So that's where that shows up. That's where you're adding 6 units to move it over. Then you have to take those 6 units away to move it back. So now the coordinates are back to 0, and we figured out the y coordinate is 7 1/2. This is tough. Oops. This is tough stuff. All right, so that's part A. I suggest you just keep going through it. Draw it on your own. You have to move these around on your own and think through these steps on your own in order to understand it. So you have to take your pen or pencil, put it on a piece of paper, and write it down and try to go through it. This is the second graph, so I'm going to call this practice problem 3B. So here's that graph right here, and this gets tough because you have to move this triangle in 2 directions. One, you have to move the triangle to the right, and the second is you have to move this triangle down. To get it, you want to remember, you want to get this point right here at 0, 0, so that you can figure out what the length along the horizontal axis is and what the length along the vertical axis is in terms of x's and y's. So that's the left side of the equation that we talked about long ago. All right, so if we move it over, we know that the horizontal direction, the length in the horizontal direction is going to be 6 units, because this 2 right here minus this negative 4, by the way, this 2 is the same as this 2. Moving 2 units along the x-axis, So 2 minus a negative 4 equals 6. And you can just see that. This is 4 units plus these 2 units right here. Add them together. This length along the horizontal direction is going to be 6 units. So that's the beginning of figuring out the slope. Well, what's the length in the vertical direction? You're up here at 7. You have to subtract, and your triangle is at 3 units right here. So you have to subtract those 3 units. So what is 7 minus 3? You have to take these 3 units away. So you lower this 3 units. So where is it? Well, 7 minus 3 is going to equal 4. So this length right here is 6 units. This length right here is 4 units. We've taken the 7 and we subtracted the 3. I think, yeah, I show that right here. So we looked at 2 minus negative 4. That equals the 6. So 2 minus negative 4 is the same as 2 plus 4. That equals 6. And also 7 minus 3. So 7 minus 3, it's 7 right here, minus 3 gets you to 4 units. So 7 minus 3 is 4. So the slope is the number of units in the vertical direction compared to the number of units in the horizontal direction. So it's going to be 4 over 6. Well, 4/6 simplifies to 2/3. And so what that's telling you, so all the triangles that we look at in this, for this problem, the number of units in the vertical direction is going to be 2/3 the number of units in the horizontal direction. So the number of units in the vertical direction are going to be smaller, are going to be shorter. And you can see that just by looking at the triangles. This length is shorter than this length. Well, this length is 2/3 of this length in the horizontal direction. All right, so that moves us pretty close to figuring out what the coordinates of D are, because we know that this relationship right here, now this is a different slope triangle, but it doesn't matter. It still has the same slope and has the same relationship. That's the whole point of slope, is that all of these triangles have that same slope. So the relationship is still going to be 2/3, but we know that this length is 4 units because we start at negative 4. And we know that the x value, the D is right on the y-axis. So the x value is 0. It goes to right here. So you're going to go from this negative 4 to this 0. That's 4 units. Well, this length is 2/3 of that 4 because it's shorter. It's 2/3 of it. It's a fraction of 4. Well, 2/3 of 4 is equal to 8/3. And 8/3 is equal to 2 2/3 units. So this length is 4 units. This length is 2 2/3 units. So we know this is 0 right here at D. So how far up the y-axis is it? Well, we know that this length is 2 2/3, but how do we get from here to here? Well, we have to add that 3 back. Remember, we subtracted the 3. So now we have to add the 3 back, this 3 units right here. Well, that 3 units plus 2 2/3 units is equal to 5 2/3. So this point right here is at 0, 0, and 5 2/3. So the y-coordinate is 5 2/3. The x-coordinate is 0. So this is probably the easier way to figure out the coordinates, just by reasoning through, figuring out the slope, figuring out where you are, and understanding the movement. Then you can get to this coordinate, 0, 5 2/3. But let's try it just using the equation. This is tougher, but we should practice doing this. So to get to the equation, I'm going to call D x and y. And furthermore, x we know is 0. So this is going to be 0.0 y. So we want to use x and y right at first to get the x and y values on the left side of the equation. We already know the right side. The right side is 2/3. That's not going to change. We figured that out. All right, so here's the equation. So the number of units in the vertical direction is y minus 3. You know that's true. This is 3 units right here. This length is, actually let's go to here. This length is 7. This is 3 units right here. So whatever y is, you have to take the 3 away. So y minus 3, and we know that for the x-coordinate, So I'm sorry, to get the length in the horizontal direction, you have to add 4 to it. So wherever you are on this, to get this length right here, you have to add 4 units to what the x value is. So the equation is y minus 3 over x plus 4. And what's that all equal? It equals this 2/3 way over here. It equals the slope. All right, but we know that x is 0. So what's the length in the horizontal direction is going to be 0 plus that 4. So that's going to, you plug in 0 and you add 4 units to it. And so what's the length going to be in the vertical direction? It's going to be 2/3 of that 4. So y minus 3 is equal to 2/3 of 4, because we know that the slope is 2/3. So y minus 3, this gets tough. Y minus 3 is 2/3 of this 4, because the number of units in the vertical direction is 2/3 of the number of units in the horizontal direction. So this length right here is 2/3 of this length. So y minus 3 is going to equal 2/3 of 4. Well, y minus 3 equals 2/3 of 4. We know what 2/3 of 4 is. We already figured that out. That's equal to 8/3. And 8/3 simplifies to 2 2/3. So why do we add 3 here? Because we subtracted 3 to move this down to here. To move this down to here, we have to add that 3 back. So it's y minus 3 is this length, but you have to add the 3 back to get to the coordinate. So have to add 3 to this 8/3. 8/3 is 2 2/3 plus the 3 units to get back to the point D here. So the coordinate, the y coordinate for point D is 5 2/3. Again, this is hard, but this length right here is 2 2/3. We're adding these 3 units right here to get to point D, to get the y coordinate of point D. We know that the x coordinate is 0. So the y coordinate is equal to 5 2/3. The x coordinate is equal to 0. So you write that coordinate pair as 0, 5 2/3. This is tough. Just keep going through it. I would go through the video, stop it, think about it, write things down, try to do the problems on your own. Keep practicing. This is practice problem number 4. And what they do in this problem is they give you 5 points, pairs of points, and they ask you to calculate the slope between each of these pairs of points and identify each of the ones that give you a slope of 2/3. And so as I wrote these down and did this problem, I started putting the point that's in the lower left first, and it turns out that A, B, C, and D, the point that's on the coordinate graph that's in the far lower left on the graph compared to the other point, they listed first in A, B, C, and D. But in E, 20, 30 is way up here. They listed that one first, and a -20, -30 would be way down here. So they listed that one second. So you're going to see that I switched them when I calculate this. It doesn't make any difference. It's still the same vertical distance, still the same horizontal distance. Just makes doing the calculation a tiny bit easier. All right, so problem A. I also labeled the first coordinate pair x2 and y2, and the second coordinate pair x1 and y1, because I'm going to subtract. Then I'm going to take the difference of the y values, so 3 minus 0, and the x values, 2 minus 0, and I'm going to use those values, that difference, to figure out the slope. So remember that the slope is equal to the number of units in the vertical direction compared to the number of units in the horizontal direction. Since these are all just coordinates on a graph, we can say the vertical distance compared to the horizontal distance. And you get that by subtracting. So this is 3 minus 0. So if you graph these, you start at 0 and you go up 3 units. So this length along the y-axis is 3 units. Along the x-axis is 2 units, because 2 minus 0 is 2. So you start at 0, 0, and you go out 2 units. That's equal to 2 minus 0 is that 2 units. And that ratio, the vertical distance is 3/2 the horizontal distance. Well, that's the opposite of 2/3. That's the reciprocal, actually, of 2/3. So this does not have a slope of 2/3. But point B, switch these coordinates. So now you're going out 3 units and up 2 units. And so how far have you gone up the y-axis? Well, you've gone up the y-axis 2 units. And so what's the horizontal distance? The horizontal distance is 3 units, because you've just moved along the x-axis from 0, 0. So that ratio is 2/3. So that does have a slope of 2/3. So that one's yes, that is an answer to the problem. So what if you go out 1 unit and then up 5, and then you go out 4 units and up 7? So now you have to imagine that you're sliding that slope triangle 2 units down. So 7 minus 5 are going to be sliding it 2 units down, and 3 units to the left. 4 minus 3 is 3 units to the left. That's going to give you a slope of 2/3. It's going to tell you that the horizontal distance is 3 units, the vertical distance is 2 units. So the vertical distance is 2/3 of the horizontal distance. Slope is 2/3. That's yes. Really what you should do is graph each one of these, draw the slope triangle, and make those moves. See it move. All right, a -2, -2 is in the third quadrant. That's way down here, and 4, 2 is way up here. So what's the length from along the y-axis is 2 minus a -2. So now you have to add 2 units to slide that up to the horizontal or the x-axis. So 2 minus a -2, that's equal to 4 units. So you slide it up 2 units. What's the length? It's that 2 units that slid it up. This slides up 2 more units. So that length is 4. And you also have to slide it to the right 2 units, because it's at -2. So now you're going to have to add 2 units to slide it to the right. And I hope you're visualizing those slope triangles. So the horizontal distance is 4 minus a -2, or it's 6 units. So that ratio is 4 to 6, or 2/3. So the length along the y-axis is 2/3 of the length along the x-axis. And also notice that it's shorter. The length along the y-axis is shorter than the length along the x-axis. It's 2/3 of the x-axis, or the length along the x-axis. And this is one that I switched. It would make no difference if you kept them in the same order, but I just moved the one with the negative coordinates to the left, and the one with the positive coordinates to the right. So now you have to add 30 units to the y value to slide that slope triangle up 30 units. So that's 30 minus a -30, or 30 plus 30. So now it's going to go up 60 units. So the length along the y-axis is 60 units. The length along the x-axis, imagine that you have to now slide this to the right, that 20 units to get it to 0, 0. So that's 20 minus a -20, or 20 plus 20, is equal to 40 units. So this is 60 units, this is 40 units. That simplifies to 3/2. So 60 to 40 is the same as 6 times 10 to 4 times 10 is the same as 6/4. That simplifies to 3/2. So no, that does not have a slope of 2/3. It actually has a slope of 3/2. So the length for this last one, the length along the y-axis, is 3/2 the length along the x-axis. So it's longer by 1/2 of the horizontal length. All right, so this is problem number 4. I would graph each of these. I would play around with this idea of slope triangles, slide them around, and these calculations will make much more sense to you if you do that.